Algebra 1, Unit 7C Study Guide, Quadratic Functions and Radicals. So these videos will help you through the study guide problems. So let's start with the first set of problems. We're going to use the properties of radicals from your Unit 7C notes to simplify. So first let's start writing in order the first 12 perfect squares. So 1 is a perfect square, 4, 9, and if you're thinking like I am, I'm thinking of 1 squared, 2 squared, 3 squared, 4 squared is 16, 25, 36, 49, 64, 81 squared is, 9 squared is 81, 100, 11 squared is 121, and then 12 squared is 144. So those are good math facts to know that'll help you solve and simplify these problems, actually. Alright, so the first one, we'll just use whatever properties of radicals that we can think of that will help us. So, first thing is that I notice I can reduce the fraction underneath the radical. So I have the square root of a fourth, which is the same thing as the square root of 1 over the square root of 4. Square root of 1 is 1 and the square root of 4 is 2. So that's about as simple as I can get it. Now with the square root of 24, it's not a perfect square, so I'm going to think of a factor pair that does have a perfect square, and I think of 6 and 4. So I'm going to rewrite this as the square root of 6 times the square root of 4. I can take the square root of 4, which is 2. I cannot evenly take the square root of 6. So that's all I can do to simplify. On the next one, we're basically going to do the same thing. I'm going to think of a factor pair of 50 with a perfect square in it. So 25 and 2. The square root of 25 is 5, and the square root of 2, well, I can't simplify that. Now on my last problem, I'm just going to split up these roots. And then all I can do is just rationalize the denominator, and I'll do that by multiplying by the square root that's in the denominator. So up top, those square roots multiplied together will give me the square root of 35. And then in my denominator, the square root of 5 times the square root of 5 is the square root of 25, or 5. So that is simplified, actually, because my denominator is rationalized. On my next problem, I can split this up so I have the square root of 9 over the square root of 5. The square root of 9 is 3, so now all I need to do is rationalize my denominator. So I do that just like I did in the problem before. I multiply it by the root in the denominator. When we simplify or multiply, we get 3 times the square root of 5 over square root of 25, which is 5. Now the square root of 32, that's not a perfect square, but I can think of a factor pair that does have a perfect square. So the square root of 16 times the square root of 2. The square root of 16 is 4, and then I'm left with the square root of 2. Same thing with 75. Let's break that up into 25 times the square root of 3, square root of 25, which would be 5 times the square root of 3. Sometimes our problems are actually simplified at the beginning. So the square root of 21, I can't break it down any further because its factors are 7 and 3, and neither of those are perfect squares. Alright, let's move on to operations with radicals. So let's look at the next set, and we'll just take each problem as we get it. So the first one, we have 3 times the square root of 7 squared. So what we're going to do is square each of those terms. So we're going to take the 3 and square it, and the square root of 7 and square it. So that'll be 9 and then 7. And we just multiply those together. So that would be 63. Now we can't subtract radicals unless they are identical. So let's see if we can break down 20. I'm going to rewrite that as the square root of 4 times the square root of 5. So I'm rewriting my first term, 7 square roots of 5, and then I can simplify this to 2 square roots of 5. And then when I subtract, I can do now, I get 5 square roots of 5. Now this is different. This is multiplying, so I can multiply my like terms together. So 2 times 4 is 8, and then my square roots multiplied together will be the square root of 20. But I need to simplify this, so I'm going to simplify it just like I did in the problem to the left. I'm going to take the square root of 4, I'm going to multiply it by the 8 that's already out there, and I'm left with the square root of 5. So my final answer, after I multiply those two terms out front together, is 16 times the square root of 5. Now in this last problem we have 5 square roots of 2 plus 8 square roots of 2, so we can combine those and we'll end up with 13 square roots of 2. Now on this next set of problems we're going to solve the quadratic equations using radicals, including those that may use the Pythagorean theorem. So just as a reminder, our Pythagorean theorem is a squared plus b squared equals c squared, and that's referring to a right triangle with two legs, a and b, and a hypotenuse, c. That's an a. Let's try that again. There. Alright, so we've got x squared plus 8 squared, so let's rewrite that as 64 equals 10 squared, so we can rewrite that as 100. Now let's just get the x squared by itself by subtracting our 64 from both sides, which will give us 36. Then we need to take the square root of both sides to work backwards, and when we introduce a square root into the problem, we give both answers, the positive and the negative. In our next problem, let's do virtually the same thing. Let's square our 3, which is 9, and our 4, which is 16. And then let's get the x squared by itself. So we have 16 minus 9 is 7. And then we'll take the square root of both sides, so that'll be x equals, and I want the positive and the negative, square root of 7. Alright, on our next problem, 3 squared is 9, 4 squared is 16, and that's going to equal x squared. So we're just solving for the different x in different locations. Take the square root of both sides, and I'm just going to move my x over to the left side, and then I have plus or minus the square root of 25, which is 5. Let's continue with these problems. So I have 1x squared and another x squared added together. I can think of that as actually 1 and 1. So together that will be 2x squareds equaling 100. So now let's just solve for x squared. So let's divide both sides by 2 and then take the square root. So we'll end up with x equals, now it's going to be positive or negative. I'm going to break this down into the square root of 2 times the square root of 25, which is 5 square roots of 2, plus or minus. Alright, continuing, we have 25 plus x squared equals 36. So let's subtract 25 from both sides. X squared will equal 11. And then we just work backwards from the x being squared, so that would be positive x, and then equals plus or minus the square root of 11, because it's not even. In this problem, if we square the 3, we get 9, and if we square the square root of 5, we get 5. Plus 4 will equal x squared. So 45 plus 4 will be x squared, or 49 equals x squared. So let's take the square root of both sides. X will equal plus or minus 7. Alright, let's do one more problem. So a right triangle has a leg of 5 and a hypotenuse of 8. So let's draw a picture. So draw yourself a right triangle. That means a triangle that has a right angle. Label one of the legs 5, and then the hypotenuse, which is across from the right angle, is x. I'm sorry, 8. And then our other leg will be labeled x. So let's write an equation. Okay, so our two legs, we want to square those. So x squared plus 5 squared, and then that is going to equal our hypotenuse squared. Now we can solve. X squared plus 25 equals 64. We'll subtract 25 from both sides. So we'll get, that'd be a 5. There we go, 39. Now when we solve, since this is a length, we don't need the negative square root of 39. And we also don't need to estimate. It didn't ask us to. So we'll just leave it in exact terms, the square root of 39. All right, this ends part 1 of the study guide help videos. So now move on to part 2 to finish out some help on the rest of the study guide 7C problems.